Honorable Deputy Director General, Natural Resource Management, ICER, the President of the Indian Society of Soil Science, all the office bearers, the past presidents, my mentors, colleagues, friends. First of all, let me thank the Indian Society of Soil Science for this opportunity to share some of our thoughts on this very, very important topic, global natural resource management research for sustainable millet production. And it's more important from the perspective since we are celebrating this International Year of Millets. I would like to take you toward this nexus, the nexus of agriculture, industry, and climate. That's what we are dealing with. And I would like to take you back when we started agriculture, the agriculture 1.0, the industry 1.0, where some sort of mechanization started happening. And that was the time when millets were very, very important crops. The millets were still important crops when we had the agriculture 2.0, industry 2.0, when electrification era started. But when we move to the era of electronics, the industry 3.0, agriculture 3.0, and that's where the green revolution started. And I think the millets were going down since then. We are at this stage where we are in the era of intelligence, where we are in agriculture 4.0 or industry 4.0. But over this period of last 60 years, the anthropogenic climate change has reduced the global agricultural total factor productivity by about 21%, which is a slowdown equivalent to 7 years of the productivity growth. If we talk about the greenhouse gas emissions coming annually, which is 18 gigatons of the carbon dioxide equivalent, the agri-food systems are responsible for a third of the global greenhouse gas emissions. And that's also coming because of many of those green revolution technologies, the overexploitation of the natural resources. And we put this one in the context of Indian economy. Each ton of the carbon dioxide equivalent emitted is costing $86 to Indian economy, which is highest globally. Now we are heading towards industry 5.0 and agriculture 5.0, and I think we are trying to correct this nexus in agriculture 5.0, and that's where we are bringing the crops which are more resilient, which are nutrient dense, and also helping in conserving the natural resources, crops like millets. That's what we are talking. So when we talk about smallholder systems in the tropics, and those farmers have unparalleled challenges because of the climate change, because the region where we are is a global hotspot for contemporary and future climate vulnerability, where our natural resources, whether it's a land, water, or biodiversity, are very, very stressed. A lot of biotic stresses are emerging because of the climate change. And this is the reason where there is a dominance of the smallholder farmers. But they are very, very important because whatever food is consumed in Asia and Africa, 75% of that food is coming from those smallholder farmers. So we cannot ignore them. At the same time, there is a clear relationship of the dominance of those smallholder farmers. And you can see it here in this global map. All the red areas are dominated by very smallholder farmers. The water limited areas, again, you can see the same region, the land degradation and the malnutrition. I think all of them are together at the same place. And that's where we are situated. And that's what we are dealing with. Now, if you talk about the global water scarcity, you can see this map where Asia and Africa, especially India and Africa, are suffering with the water. About 1.4 to 4 billion people are facing the water scarcity for the months ranging from 1 to 12 months. And around 4 billion people are facing the water scarcity with a minimum of 1 month in a year, whereas half a billion people are facing water scarcity across the 12 months. That's the kind of scenario we are facing. Now, if you come down to India, and again, the climate change is impacting the groundwater depletion. And if you can see, if you move from the left to the right, I think the challenges are bigger and larger in terms of the groundwater depletion. And with the projected climate change, the situation is more serious, more severe in terms of the groundwater depletion, which is a serious challenge. And I think the business as usual is not going to help us. Same is the case for the global extent and degree of land degradation of different kind, whether it's a chemical or the physical or the water related problems, acidification, salinization, all those problems. And again, the problems are more or less in the same areas where we are based. So that's another problem. Now, this prevalence of the soil and ecological degradation is leading to the political instability and regional conflict. And if we talk about the human population in South Asia, it's a 2 plus billion today, which is expected to be 2.5 billion by 2050, which is adding to this whole problem of the conflict. So we need, to produce more food. That means we have to expand the agriculture with a per capita decline in the area, with a lot of erosion and salinization and soil organic carbon depletion happening, which is leading to reduction in the food production and nutritional quality. There's a lot of issues of the floods and droughts and weakening of the ecosystem services, and that lead to the intensive use of the fertilizers and pesticide and irrigation energy-based inputs and leading to the lot of greenhouse gas emissions, and that lead to the human suffering because of the poverty, because of hunger, malnutrition, and diseases, and that lead to finally the political unrest because of wars and refugees and things like that, and which will have ultimately the global unrest and political instability. And I took from one of the papers just came out from Professor Ratan Lal. If we talk about India, we are suffering with land degradation problem of 146 million hectare. The land, agricultural land availability per person is diminishing. We are sitting at 0.13 hectare per person, and the malnutrition is rampant. So 190 million people are suffering with malnutrition problem. Now, in that context, the millets are something very, very important. So the millets are the champions of the drylands. And I think that's a classical and historically millets have been grown in the drylands. If you look at the spread of the millets across Asia and Africa, I think everywhere millets are grown, but the majority of the concentration is here in India and also in some of the West African and Southern Eastern African countries. That's where millets are grown. Now, millets are resilient and nutrient dense crops of antiquity. And I think from that respect, if you talk about the benefits, what we can accrue out of millets is the environmental benefit because of reduced soil erosion, improving the soil health, and save on the water. That builds on, to the climate resilience through mitigating the drought and heat tolerance. And millets can thrive in marginal soils. Millets are contributing nutrition health through the gluten-free and nutrient-rich source of the food, low, glycemic index, and that also put into the economic benefits because that needs less inputs and shorter season, and that can lead to the value-added projects and also contributing the socio-cultural importance because there's a cultural significance of the millets, for example, in tribal areas, rain-fed areas, and that can revitalize the rural economy and food security. So millets are the versatile crops and that can best fit for the sustainable intensification in many of the production systems. But still, these are least preferred crops because of the systemic challenges, and we have to address those systemic challenges. So when we talk about systemic challenges, I think we have to have the innovations in the system design. We need a system thinking. It's not very simple. We are dealing with the complexity. And when we talk about system thinking, that means the mental construct that recognize the pattern and connections in a particular complex system to make the best decision possible so that millets can come, find their place in that system. And that's why we talk about system thinking. Once we have the higher degree of the system thinking, which is associated with the more successful strategies for the better decision making under the complex environmental, cultural, and social settings. And that's what is really required if we really want to push millets into our farming systems. And in that context, the cognitive neuroscience hold the key to improving the environmental decision making, whether it's a millets or any other sustainable farming practices. So I think we need to deal with this complexity of the neuroscience and that connected to the decision making for agriculture, for sustainable farming practices, or having millets into the systems. And in that context, I think we need to move from a microbiome to plant to the landscape and the markets. That's the kind of holistic approach we need to have. We cannot do things. We are more or less at the plant or the field or the farm level. I think that's not going to help us if we talk about having millets into the farming system. We need to think about the landscape and the markets. And that's why we need a holistic and integrated approach at the farm and the landscape level, working in partnership with all the users or the key stakeholders. And in that context, we need to work at the three levels for making this shift towards the climate resilient agri-food systems. So we need to work at the farm level, we need to work at the landscape level, and we need to work at the entire food system level. That's what is really required. We cannot have millets, integrated in isolation at the plot or the farm level. I think we need to have that the landscape to the socio-ecological scale strategy. And I would like to cite some examples on the natural resource management related research on millets across Asia and Africa. And this is one example coming from my colleagues working in Sahel in Western Africa, where soils are poor, pH is low, acidity is a problem, low organic matter content, and there's less of availability of the fertilizers or the nutrient. So the long-term soil fertility management using the micro dosing in the pearl millet have shown here over years, and that can indicate that you can double the productivity of the millets with the micro dosing, which is something very, very important. Now, also the microdosing of the compost in the sorghum, and this is example coming from Mali, again in Western Africa, from the work which our colleagues have been doing with the national systems in Mali. And you can see that with the microdosing, there was an improvement in the grain production, biomass production, and nitrogen use efficiency by 47%, 27%, and 55% respectively. Microdosing of the compost, at 2.5 ton per hectare resulted in an economic gain of $560 per season, which is 27% higher than what is obtained with the application of the compost by broadcasting technique at 5 ton per hectare. So you are reducing the compost application by half, and you are improving the profitability of the farmer through improvement in the productivity. And you can see that on the right side bottom, the spider diagram, what microdosing can contribute in terms of improving the productivity of the millets. At the same time, there is interaction. So we find that these three sorghum varieties in Mali, along with the multiple choices of the fertilization strategies, that resulted in 32 to 72% increase in the grain and biomass yield, which are now recommended for larger scale adoption in Mali. So that's another example of microdosing of compost. Now, one more example, when we are dealing with the uncertainties of the weather or the rainfall, I think we need to have strategies in place, and that's what our colleagues been doing. So this is another example coming from Niger in Western Africa, where the transplanting of the seedling of the pearl millet are helping farmers in adapting to the climatic risk. And this pearl millet seedling transplantation reduced significantly the physiological maturity from 74 days after planting, compared to the 61 days, which is a reduction in the 13 days, which makes a lot of difference when we are dealing with the water limited geographies. And that also increased 30% increase in the grain productivity, and I think 30% is quite significant number when we talk about these regions where there are a lot of problem of food insecurity. We've been working here at the ICRISAT headquarters at Hyderabad on developing those regenerative agriculture practices for the millet-based systems. And this is one example I'm citing from the red soils. And you can see the conservation agriculture or regenerative agriculture, which is inclusive of conservation agriculture, which means permanent white beds with residue retention and intercropping of the millets with the groundnut. And you can see this is the initial stage on the left side. On the right side, you can see the healthy crop of sorghum and the healthy crop of the groundnut. I think it's a win-win. So that's how you can integrate millet into those systems. And I think whatever nitrogen is fixed by the groundnut is available in season to the sorghum, and that's why the sorghum you can see the healthy crop. There's another example of groundnut plus pearl millet and the same red soils, and you can see on the left side the pearl millet and the groundnut, on the right side where you see the healthy groundnut where we have harvested the pearl millet, a good crop. So you can have the two crops in the rain-fed situation, and you can integrate your millets into the cropping systems. And that is also with conservation agriculture, no-till residue retention, and the inclusion of the microbial culture into the system. Now we also got regenerative agriculture in millet-based systems in the vertisol. So you can see this picture on the top right, where we have different cropping systems, including the millets. This is a winter season, so you can see the sorghum. And to do this, we also designed this planter we call a dryland magic planter, which is capable of planting any crop of which are dryland crops of with any land configuration, whether it's raised beds or the flat beds or the absolute no-till or strip till, and you can have the intercrop. So that's a multi-crop, multi-utility planter. So designing a system is important, but how to plant it is also important. So we got this planter design, and this is kind of result what we got. So these are the different cropping systems you can see, and this is all yield of the winter crops only, not the full system. But the soil test-based fertilization coupled with the mulch and coupled with the biological consortia, and you can see some incremental changes here, and that's taking us towards a kind of regenerative agriculture. The highest productivity we got is in sorghum, winter sorghum, with this regenerative agriculture practice. So that's another example how we can integrate millets together with the regenerative farming practices. Now, these are the examples coming from the plot level, the research. Now I'm moving toward the farm level research, and that's another example coming from Mali, where we got a cattle night crawling, which is having impact on sustainability of the sorghum-based systems. And you can see because of the problems what I indicated, the low pH soils, low organic matter, lot of land degradation problems, and fertilizer scarcity, where rather than throwing the FYM, we got this innovative approach of cattle night crawling, which is helping us. And I think if you can see the no nitrogen versus DAP versus 3 days of night crawling, 7 days, 10 days, and 15 days of that cattle night crawling is contributing to the multi criteria or multiple indicators of the sustainability. If you see the productivity have moved from here to here, the economic gains again increased significantly, the environmental benefits improved, and the food security improved. So I think that's a one example of how we manage our natural resources in those kind of situations. So the cattle night crawling is an innovative technology for improving the productivity and sustainability of the dryland crop livestock farming systems with a larger scalability potential, because livestock is the lifeline. But if you can make a good balance between the livestock and the crops, can really help us in transitioning to the sustainability. There's another example, which is now I'm moving toward the landscape. So from plot to the farm to the landscape. And I think this is example coming from Afar region of the Ethiopia, where pearl millet and sorghum for the dryland agropastoral system, and we are using the water spreading weirs in that region, and that how that at the landscape scale can help us in improving and designing the system. So it's spatial planning for what is good for and where. So the diversification potential and designing those system at that landscape, and then bringing them, and which is helping us in improving the landscape scale productivity and profitability of those systems. Now, I'm also on the landscape space specific nutrient management. We talk about site-specific nutrient management, but still we are dealing at the plot level. And I think that's not going to take us long. So we are working on the landscape-specific nutrient management, and this is another example coming from Ethiopia, and a very, very innovative one. So what you need, the kind of landscapes here, what you need on the top of the landscape and the bottom of the landscape is not same. So you have to design your nutrient management and optimize so that you can make best decisions at the landscape scale, and then you design your systems and you can see how the landscape specific nutrient management is helping. So you can hill slope side or mid slope side or the foot slope side, and you can go those different crops, and you can see how the soil moisture varies in those slopes, and how the nutrient management, combined with the soil moisture, can help us in improving the landscape productivity and efficiency and minimizing the environmental footprints at those landscapes. So with these, some of the examples, what I got, I would like to put a few key messages, which I think we can take home. The first one is millets are no more subsistence crops. These are rather critical for achieving the targets of One Health within the planetary boundaries. So I think we have to make millets more productive, more efficient, so that we can achieve the target of One Health within the planetary boundaries. But for that, I think the single learning loop, and when I say single learning loop, working on varieties in isolation or working on different component technologies in isolation, which is a single learning loop, is not going to help us. So we need a double or triple learning loops. That means genetic to socio-ecological level, integration of all those things, not in isolation. So we need triple learning loops if we really want to transform the agri-food systems, especially in the drylands. But at the same time, the research on the natural resource management in millet-based system is still very, very limited and in silos. And I think we cannot afford to continue that. We have to strengthen the research on natural resource management and the millet-based systems, are very, very holistic at the system level. There are large management yield gaps which need a strong focus on the NRM research. If we talk about the productivity of the varieties, whatever available today, millet varieties, we got high productivity varieties, but realize the yield are very, very low. So we got 100 to 200% management yield gaps. And I think to bridge those gaps, we need a strong focus on natural resource management research. At the same time, we need a systems thinking with the landscape approach, integrating the crop, livestock, and tree, and taking us toward the agri-food systems approach. I think that's what is really required. No, not only the production, but production to consumption, where markets and value chains also comes into the picture, and everything is linked. So I think we cannot afford to work in isolation. And when we talk about the systems research, I think that's bringing everything together. We need a greater emphasis on defining the domain of the millets. And when you say millet, but millet cannot go everywhere. I think we need to define the millets domain with an optimized system. What is the best fit cropping system? The intensification options, whether the intercropping or relay cropping or sequential cropping or opportunity crop, because of the shorter duration nature of the millet. There are millets which can be grown in 65, 70 days. And I think that provides us an opportunity for intensification of the systems. For example, if we can talk about sugarcane systems and say short duration millets can go there when sugarcane is still slow growing, and we can have millets into the system, but that needs a lot of natural resource management research, including of the optimization of the cropping system and their associated management practices. So these are some of the thoughts. We also need to have the research beyond the yield. I think yield is not only the factor. We need to think about the multi-criteria. So the income opportunities through ecosystem services, when you bring millets into the system, and let me cite the example. If you replace rice with millet in Punjab, I mean, it create ecosystem services to the tune of 15,000 plus rupees per hectare per season, and that can add on and bringing millets into the system and make our systems more resilient and sustainable. So with this, thank you so much for this opportunity, and I'll be happy to respond any of your queries and questions if you wish and have. Thank you so much.